Definition of a logarithm base b. You might recall from earlier this school year, we studied logarithms. So remember that if b is a constant such that b is greater than 0, b is not equal to 1, and x is greater than 0, then b to the y power equals x means log base b of x equals y. Notice that the y is the exponent in the exponential form. Okay, so in the logarithmic form, the exponent is going to be the answer. The base is always the base, so that is what helps me to keep it straight. So the base is the base, and the y is the exponent on the exponential form. It's the answer on the logarithm form. So the expression y base b of x is the logarithmic base b of x. Example 1. Evaluate the logarithm a log base 10 of 1,000. So remember, the form is b to the y power equals x, and then log base b of x equals y. So our base is 10. The 1,000 is our x. So we're going to have 10 to the y power equals 1,000. So 10 to what power equals 1,000? 10 to the third power equals 1,000. So y equals 3. B, log base 7 of 49. 7 is my base, 49 is my x. So I say 7 to the y power equals 49. Well, 7 to the second power equals 49. So y equals 2. C, log base 2 of 32. Well, my base is 2. 32 is my x. So I say 2 to the y power equals 32. 2 to the fifth power equals 32. So y equals 5. D, log base 81 of 3. So 81 is my base, 3 is my x, so I have 81 to the y power is equal to 3. Well, notice this one's a little bit different. We actually need to divide 81 by 3 4 times in order to get 3. So that would be 81 to the negative fourth power is equal to 3. So y equals negative 4. E, log base 4 of 1/64. So my base is 4. 1/64 is my x. So 4 to what power, y, or to the y power equals 1 over 64. Now because I'm ending up with a fraction, I know this is going to be a negative. So I would have 4 to the negative y power is equal to 1 over 64. So basically, I have 4 to the negative 4th power is equal to 1 over 64. So y equals negative 4. Properties of logarithms. Let b, m, and n be positive real numbers, b not equal to 1, and p be any real number. So when we're working with logarithms, we have different rules that we may use. First is the product rule, meaning if I'm multiplying two numbers or two expressions inside the parentheses in a logarithmic expression, then, for example, log base b of m times n is going to equal to the log base b of m plus the log base b of n. So when you're multiplying, you're going to add the two expressions together. The quotient rule, log base b of m divided by n, is equal to the log base b of m minus the log base b of n. The power rule, log base b of m to the p power. So we're raising it to the p power. We bring that p in front of the log expression. So it'll be p times the log base b of m. So the expression, that p will come in front of the logarithmic expression. For the inverse rule, b to the log base b of m, notice the bases are the same. When the bases are the same, your answer is simply going to be m, whatever this value is here. Common log means that when there's no logarithm base written, the base is automatically base 10. And natural log uses the letters ln for natural log, and that means that it's log base e. Example 3. Solve 4 to the x power equals 7 for x. So we're going to again use the relationship that we've seen before, that b to the y power equals x translates to log base b of x equals y. So 4 is my base, x is my y, my exponent, and then 7 is my argument. So I will say log base 4, remember the base is always base, of x, which is 7, is equal to x. So all I have to do now is just plug this into a scientific calculator, and when I plug that into my scientific calculator, and I'm going to round this, so it's going to be x is approximately equal to 404. Example 5. The more alternatives people have in making a decision, the longer it takes them to select one. This relationship known as Hicks' law, can be modeled by a logarithmic function. Preguntas works for the Census Bureau of a small country and is trying to estimate the average time it will take respondents to answer some basic demographic questions. She has conducted a small pilot study, the results of which are shown in the table. Make a scatter plot of the data and fit a logarithmic regression function y equals natural log of x to the data. So copy this data into a Excel spreadsheet, select the data, insert a scatter plot chart, add a chart element trend line, and then click on the trend line and format trend line, select logarithmic, and you should see this. So again, put your table, select it, click insert, and then select the chart, the scatter plot. Click on the chart, select add chart element in the upper left-hand corner, select trend line, go to more trend line options, and then select logarithmic. Finally, display the equation on the chart, which is the last, next to the last option in the format trend line box.